Hello, this is our second video today, and we will be looking at solving linear inequalities. Inequalities with only one variable. You know already we can graph problems like this. So, whenever we have less than or greater than, we will be using empty circles. And when we have less than or equal to or greater than or equal to, we will be using the shaded circles. Okay. So for example, x is greater than -3. We will be looking for -3, and we will keep the circle clear, and we will be going, because it's greater, the x is greater, you know that the greater is always to the right. This is our graph for this problem. Next problem, x is less than or equal to -1. So our endpoint is -1. That's between -2 and 0, right? It is a part of the interval. You see the sign here. And we are looking for x that is less than or greater to. So we will be going left. That's where the smaller numbers are. So -6, -4, all those numbers are less than -1. This is how it works when we are trying to solve by graphing. Now we will be looking at transformations that produce equivalent inequalities. You will see, and you have tried it before, that solving inequalities is very similar to solving equations. There are very few differences. Most of these things will be exactly the same with equations as well. So, transformation applied. Add the same number to each side. Okay, this is what we need to do when in our original inequality we were subtracting. So we undo the subtraction by adding. We will add 5 to both sides. Just remember, always do it with the same number. Keep it the same. And what we get is x on the left hand side, because x minus 5 plus 5 is x, is greater than 14. Wonderful. Now our next problem, x plus 4 is less or equal to -2. We will have to undo it by subtracting the same number. We will be taking away 4 from both sides. We will get x on the left hand side. We will have to keep the sign exactly the same, less than or equal to, and then -2 minus 4 is -6. Okay, we are basically adding two negative numbers, or we are taking away positive from a negative. In any case, it's getting the number smaller and smaller. It's going to be -6. In our next problem, we have 1/8 x is less than -3. And we are basically dividing, right? 1/8, it's dividing by 8. So what we will do is we will multiply by 8. And just remember again, let me change colors just to make it a little more fun. Remember again, we have to do the same thing on both sides. I cannot tell it enough. It is very important. Multiplying by 8. 1/8 x times 8 is x. That's what we wanted. Wonderful. We have to keep the sign same. And then -3 times 8 is -24. In our next problem, we have 7x. And you probably remember 7x is the same thing like 7 times x. So we have multiplication, and we undo it, we solve it by dividing. We will be dividing by 7. Okay, 7x divided by 7 is x. 35 divided by 7 is 5. Now we have -x is less than or equal to 12. And now this is one of very few differences between equations and inequalities. With equation we do not have to worry about. We remember that we just need to basically multiply by negative number, by -1, and that's it. When we have inequality, we have to remember to flip the sign. Very important. Reverse the inequality. I will circle it here for you. So, when we solve that, we will get x on the left-hand side, minus 12 on the other. But remember, the sign will be opposite. X is going to be greater or equal to negative 12. And I just want to give you an example so that you know for a fact that it's not something you just memorize. This is something that you know. Let us take a very simple example. 1 is less than 2. Okay? When we multiply this inequality, we will get -1, -1, -2. Look at those two numbers. Which one is smaller? Which one is greater? I hope this is clear to you. -1 is bigger than -2. So we absolutely have to flip the sign when we are dividing or multiplying by a negative number. Okay, this is just an example to illustrate it to you. Let's go to the last example of on this page. We have -6, so we will be dividing by -6. What do we get? We get x on the left-hand side. We'll flip the sign, and 42 divided by 6 is 7. This is going to be our solution. I hope it all makes sense to you. And let me just solve problem A, and I'm really looking forward to solving many more problems in the class. They want us to solve and graph this problem. So this one takes little bit more steps. We have 11x minus 9 is greater than 13. I always imagine like I'm an archaeologist when I'm solving problems like this. I have to figure out how to get that x out, how to express, how to solve this problem without damaging it. So what do I undo first? I first undo the subtraction by adding 9. Okay, we will get 11x is greater than 13. Yes, and now we have gotten a very nice problem that is easier to solve. Oh, I made a mistake there. I apologize for that. What did I do wrong? Did you catch it? I hope you did. So I forgot to add that 9. You see that? I wrote it down there, but I didn't do that. So I hope it's a lesson for all of us. 13 plus 9, it's 24. Wonderful. Oh, I'm really getting tired. Well, I hope you excuse me. I'm recording this video really late in the night, but I want to have it ready for you guys. 13 plus 9. Another try. 22, Mrs. B. Wonderful. Thank you. What do we do next? Next, we have to undo multiplication. We will be dividing by 11. Both sides, remember. So we get x on the left-hand side, and because it's a positive number, we don't have to worry. It will be the same sign, and we get 2 on the other side. Now it's time to graph this problem. We know an endpoint of this problem is gonna be 2, and it's gonna be an empty or clear circle because number 2 is not part of the answer. And then we are looking for x that is greater than 2, so we will be going to the right. Okay, wonderful. This is our solution. I want you to circle the final answers, and this is the graph. So we did exactly what they wanted. Solve and graph. Please try to do problem B, and I'm looking forward to reviewing everything and doing many more problems in class. Have a good day.